Okay, so Unit 1, Lesson 3, Investigation 2, Solving a System Using Elimination. Okay, get started. Let's look at page 54 in our books. Page 54, the second paragraph gives a cool story about three friends. All right, here is the story. 54. It's right there in blue. Okay. Now, Conrad, Jenna, and Andrea. Give Andrea, not Andrea, so it's not her. All right. So Conrad, Jenna, and Andrea went to Wild Adventure Theme Park during the summer vacation. No, I don't know where that's at. Okay. At lunch, Conrad offered to get 2 slices of pizza for Andrea, and Jenna offered to get a drink for Andrea. While Andrea looked for a table where they could sit together. Prices were not posted at the small pizza stand, but Conrad was charged $10.50 for 4 slices of pizza, Maddie, and 1 large drink. So what is Conrad's equation? What do you think, Maddie? 4 slices of pizza, 1 large drink costs him $10.50. What's the equation look like? What do you think? What? I know you weren't. So 4 slices of pizza, 1 large drink costs $10.50. What do you think the equation is?
10.50.
10.50.
X.
No.
Equals
4p plus d. 4 slices of pizza, 1 large drink. Does that make sense?
Yeah.
Cost $10.50. Okay. Now, Andrea, Jenna was charged $7.50 for 2 slices of pizza and 2 large drinks. So Jenna bought Andrea her drink. So what's the other equation? Maddie, will give you a second chance. $7.50. Come on now.
I'm trying to find my leg for my pencil so I can
All right.
put it down.
All right. $7.50 for 2 large drinks and 2 pizzas. What do you think, Ethan? $7.50 equals what?
It's right there.
2P
plus
D.
2D. Perfect. Okay. Does that make sense? Those equations make sense, guys? Yeah? Okay. Andrea wanted to pay her friends back for the food they bought for her, but at first, all they could figure out was a system of linear equations that expressed their conditions. And that's the linear equations we figured out. So, in this linear equation, Jamira, what does the P stand for?
I'm not paying attention either.
What does the P stand for?
Pencils.
No. Pizza. What does the D stand for?
Drink.
Drinks. Perfect. Okay. P is for pencils, D is for drinks. Does that make sense, guys?
Yeah. Wait,
Okay.
you
P is for pizzas, D is for drinks.
Wait, you just told Jamara I was wrong.
Yeah.
You know, this is kind of like the worst hour you should be. No, it's right.
No, you guys do a great job. All right, so, class, the first step is the longest step, right? But there are 4 steps for solving a system equation using elimination. So here's the first step, all right? Now, we'll go through it together, so just start writing down that first one after number 1. There is, however, ladies, I want you to listen, see I mess up. Okay, so I should write in pen, okay? There is a 0th step. And then you're saying, what's the 0th step? Well, the 0 goes before the 1. And the reason I go with the 0th step is because if I do the 0th step right now, then you guys will be like, why does that need to happen? Well, if I tell you it later, then it makes better sense.
Wait.
So leave a little space for the 0th step. So leave 1 line between steps and 1. Okay? So leave 1 line where you're at steps, leave a line there.
Or you can just not erase the steps, and then I can just write all the steps.
Okay, that's fine. All right? But the reason why is it'll make more sense later. So the first step, examine the system of equations. Okay? Find coefficients that are multiples of each other. What does multiple mean?
More than 1.
Nope.
What?
It usually does. Okay? It means we can times them, right? A multiple of something. 2 is a multiple of 4. Okay? Or sorry, 2 is a factor of 4. 4 is a multiple of 2 because I multiply 2 by something and I can get 4. Okay? So a multiple means it's a number I can multiply one of my numbers by to get that number. Okay? So multiples are things we can multiply a number by to get that number. So it'll make sense here in a second. Take my space up, aren't you, Josh?
I swear this pencil is
All right. So are we copying these down? We got the first step down? Okay. So remember our equation was 10.5 equals 4p plus d. 7.5 equals 2p plus 2d. Now, are there anything in this equation that are multiples? Are there any numbers in our equation that are multiples?
Yeah.
Which ones, Josh?
4.
And?
D. I'm just playing.
4 and 2, aren't these multiples?
Yeah.
I take 2, I multiply by 2, and I get
4.
4, right? We also have multiples here because this has a what in front of it?
1.
A 1. So 1 and 2 are also multiples. I multiply 1 by 2 and I get 2. Does that make sense? So in this equation, 2p and 4p work because 2p times 2 equals 4p. Does that make sense, guys?
No.
Okay, Maddie, I'm looking for...
I was just kidding.
Okay. Are there any questions?
Can I do a pencil one? Yeah.
I have a pencil you can borrow. I have a pencil with lead in it.
I can't. Here. Gotta give it back.
All right. You probably should take some collateral. Take her shoe. That almost was a squirrel pencil. You gotta watch out. All right. So, back to this. I know you're probably saying, well, what if there is a system of equations where I can't find multiples? That's what the next arrow is for. If there are no multiples, pick a variable and multiply the coefficients by each other. Okay? So, for example here, what did I pick for my example?
Is that an and sign?
Yeah, it's an and sign. The and for stand takes so long to write, so just use this one. Okay. So, are 3 and 5 multiples of each other? Can I multiply 3 by something and get 5?
No.
Can I multiply 5 by something and get 3?
No.
No. So if I'm ever in this case, what you do then is you take 3y and multiply by what?
Coefficient.
The 5, the other coefficient. Okay? And we'll take 5y and multiply by what?
3.
3. Because when I do that, we get 15y here and 15y there. Now you're probably wondering, why do I want to have the same coefficient on the variable? And we'll get to that here in a second. Okay? We'll get to that in a second. Right? But what you want, before we go on to step 2, is you want...
Okay.
Maddie, you're throwing me off. I can't even think of the lesson so much.
Sorry.
All right. So, we want variables... Man. We want the same variables to have the same number. Okay? We want the same variables to have the same number, and I'm putting parentheses after that, plus or minus. Okay? Like if I have 5 and negative 5, that's okay. We want the same variables to have the same number. Oh, I do that. The same variables have the same number. Wow. Coefficient. So this is what we want. We should put a little "we want" in front of that, so it's a little more attention to it. We want.
It sounded like you said we walk.
We want this. So we want the same variables have the same number of coefficients. So in order to do that, what do we need to do? In order to do that, what do you think we need to do?
Multiply them by themselves.
Okay, we can multiply the two numbers by themselves like this, like 3y times 5 and 5y times 3. We can do that. There's no multiples. Or if there's multiples, we take this. We take 2p and 4p. To turn 2p into 4p, we have to do what? To turn 2p into 4p, we have to do what? Multiply by the number. Okay? So what we do then is we multiply or divide our coefficients so that two variables have the same number. So I guess that's kind of the short step one. Okay? So basically the result of step one is multiply or divide one equation so that the same variables have the same coefficient. Okay. So, step one, probably the longest step of all three methods. Okay? But once you get done with step one, guys, it's super easy after that.
Are you sure?
I'm very sure.
You said that last. What's step 0 then?
We'll get there.
Step 0 is supposed to go before step 1.
It does. We'll get to step 0 in a second. Yes. Guys. Thank you. Are there any questions about the first step? Okay, let's try it then. So our equations, we have 10.50 equals 4p plus d, and we have 7.5 equals 2p plus 2d. We'll cut it over here. Bless you. Okay. Now, I need to multiply or divide one equation so that the same variables have the same coefficients. Now, the whole part about looking for multiples, that's how you figure out what to multiply. We said we had multiples, 4 and 2, right? Right?
Yeah.
So since these two are multiples, Josh, that means I need to try to get these two the same, right? So how can I get these two the same? Multiply what, Lon? Multiply this 2? You're going to check multiply this 2 by what? By 2. If I multiply this 2 by 2, 2 times 2 is 4. Perfect. So what I'm going to do, I can't just multiply that by 2. Got to multiply the whole equation by 2. Because it's algebra. Whatever you do to one side, you have to do the other side, right? If I want to multiply this by 2, I got to multiply that by 2 and this by 2. Otherwise, the statement is no longer true. Okay? So it's like saying, instead of buying 2 pizzas and 2 drinks, I'm not going to buy 4 pieces of pizza and 4 drinks. Right? So then that makes my price is going to double unless there's some kind of special, right? We're assuming there's no special. Okay? So what happens when I multiply? Well, this means I got to distribute everything through. 2 times 7.5 is 15. 2 times 2 is 4. 2 times 2 is 4. Now, did we achieve what we wanted? Did we want the coefficients? We wanted the coefficients on the p to be the same number, right?
Yeah.
Are they the same now? Yeah. So now we can go on to the next step.
Okay. Why did we put there?
Because the looking for multiples is the way you figure it out.
Are you? What do you mean?
Well, I asked you to look for multiples, right? Look for things you can multiply to get the other one, right? That's how you figure out what you need to multiply by. Okay?
So
And
do a harder one.
we'll get to one in a second. We're not done yet. This problem's not done. Okay? Step 2. Step 2. Add or subtract equations to eliminate one variable. So, Josh, we're going to add or subtract equations to eliminate one variable, right? So we have our 2 equations. Our 2 equations from the previous step are 10.50 equals 4p plus d. And remember, we multiplied this by 2, so now we have 15 equals 4p plus 4d. Now, what variable can I eliminate here? P or D?
P.
P. If I'm going to eliminate P, what am I going to do with these equations? Am I going to add them to each other or subtract them from each other?
We're gonna want to subtract.
We're going to want to subtract them from each other. So what we do then is we subtract this whole equation right here from the equation above it. Okay? Now you don't just subtract part of it, you subtract the whole thing. If I need to subtract the p's to get 0p, then that means I have to subtract the d's and I have to subtract the 10 and a half to the 15. Alright? The biggest mistake students make is they subtract the part they want to, and what do you do with the rest?
Just leave it the same.
You either leave it the same or they...
Forget about it.
Nope. That'd be leaving it the same. Or they add it. Okay? If you're subtracting, you need to subtract. Alright? Everything needs to be subtracted. Alright? So, 10 and a half minus 15. Negative 4.5. 4p minus 4p.
0.
0p. And that's what I need right there. That's 0p. Because now my p's are
Gone.
gone. They're eliminated. Hence the name elimination. Okay? D minus 4d. Negative 3d. Okay? So I can rewrite this like this.
Wait, why?
So she owes the negative 4.5.
We'll get there. Okay? Yes, Faith? Why can we do this step?
So you don't really have a choice of either here or there.
No, you can pick.
Well,
It-
how would you get rid of D? No.
Okay. If I want to get rid of d instead of p. Rebecca, please pay attention. Joanna, please pay attention. If I want to get rid of d instead of p, it all goes back to here. Instead of choosing 4p and 4d, I would choose 1d and 2d. Okay? Instead of multiplying by 2 here, okay, we would have multiplied the top equation by 2. So then my d's would have been the same. Okay? So then I had 21 equals 8p plus 2d, and I'd subtract that from this one. Okay?
Also, like, if you pick from here,
Yep. So we picked p, so we're trying to get rid of the p's first. Okay? Since p worked out, Josh, okay, that's the one we're trying to eliminate is the p. Okay, since p had the multiples. Okay, does that make sense? Okay. Now some of you are probably wondering, why can I do this? Why can I subtract? Okay. These two quantities are equal, right? 15 and 4p plus 4d, aren't they equal? So I can subtract 15 from one side and 4p and 4d from the other side because I'm doing the same thing to both sides. So that's why this step works. That's the mathematical theory. Long, you said you don't understand. What don't you understand?
I don't know.
You don't know? Okay, how about we finish this one? We'll try another one. Let's see if that helps. Okay. Now, step 3. You guys are going to love step 3.
that was
Okay.
just
Probably the easiest step in all the solving we've done.
rewrite it.
Okay? Step 3.
Oh.
Solve for the remaining variable. Now the reason why I say this is probably the easiest one, because if I look, negative 4.5 equals negative 3d, that's a one-step solving problem, isn't it? Just divide. Okay. So we have negative 4.5 equals negative 3d. Right?
Branch,
Yes,
spell the remaining wrong.
I did. Remain?
What up, man?
There you go. Probably too small to read, but that's all right. It's right now. I get excited and I leave out things. That's fine. All right, so now what do I do? You guys all said it a second ago. We divide. So we divide by what? Negative 3. Negative 4.5 divided by negative 3 is? 1.5. So 1.5 equals D. So how much do drinks cost? 1.5 what? Dollars. Easy step, huh?
Yeah.
Yeah. What do you think step 4 is?
What?
You said that
Oh, I said it was the easiest step. I didn't say it's the last step.
Put that in the equation.
Good. Plug our results into either of the original equations.
He said there was
So there's 4.
Is it
He
unbelievable?
said 3, didn't he? When he did the first step. He said that this was going to be.
Yeah.
Whatever.
Next time I order a pop, I'm
Watch
gonna do
the
all
video.
of this to see how much it costs.
Sounds like a good idea.
That would take too much time.
It would not.
Yes, it
I can solve one of these in 6 minutes. I almost said 6
That's
seconds.
a lot of time.
That's a lot of time.
For one problem.
All right. I've now been doing this all my life. It's parts of it. All right. So we plug our result into either of the original equations. So either of the original equations, the 10p or the 10.5 equals 4p plus d, or the 7.5 equals 2p plus 2d. You can plug into either one. So which one do you guys want to plug into? 10.5 or 7.5? 10.5. Okay. So we take 10.5 equals 4p plus d, and wherever we see a d, what do we write? 1.5. Okay. So now what do we do?
You minus 1.5.
Good. We subtract 1.5.
Algebra.
So now we subtract 1.5, right? So 10.5 minus 1.5 is 9. So 9 equals 4p. What do we do now? Divide by 4. Okay. 9 divided 4 is 2.25 equals p. How much is a sliced pizza? So there you have, guys. You guys have now solved using elimination.
What's the too much?
We'll get there.
Shout out to
All right. Are there any questions? You have any?
Yeah, one way multiple does have a multiple sequence.
Yeah, decimal multiple, right?
Yeah.
You can use decimal multiples if you want to. Okay. Rebecca? We'll get there.
No, if we don't talk,
Okay.
it's just like.
Step 0. All right. So can you guys all see the steps still? Hopefully you're watching at home. You wrote them down already. So step 0. The thing about what step 0 is, we need to look at a different system. Because this system started out with our P's and our D's both on the right and our numbers on the left. Right? So what do you guys think step 0 is going to involve? Moving them around. Okay?
So you're going to show us an easier way then.
Nope. It's not an easier way.
So is it harder?
It's not harder.
What is it?
It's just adding the 0th step. Okay? So let me look at a system. We have 3x minus y equals 6. Okay? And then we have, ladies, please pay attention. And I'm going to have x equals 5.5 minus 2y. Okay? So here's my system. Okay? Yep, 5.5. Now, how is this different from the P's and the D's? Well, the P and the D problem, we had number equals P plus D. Right? Right? The 0th step is to use algebra to get the same variables in the same column. Yep, step 0. Use algebra to get the same variables in the same column. Okay. You're probably saying, what do you mean by column? Well, here I have x equals, right, 5.5 minus 2y. 3x minus y equals 6. The only ones in the same column here are x's. They're both on the left side of my equal sign, right? You guys see that? The line straight down. My equal sign is in the right spot because my equal signs need to be by each other or across from each other. Okay? 5.5 and y, they're in the wrong spots, aren't they? 6 and negative 2y, they're in the wrong spots. So I need to get them all lined up in the same column. So which equation do you want to look at? The top one or the bottom one? What do you guys think? Bottom? Okay, Long, what do you want to do with the bottom one? Where do you want to put the 2y? Where do you want to put the 2y?
On the other side of the equal sign.
On the other side of the equal sign. Thank you, Faith. How do I do that?
You add
We add what?
2y.
2y. So we get x plus 2y equals 5.5, right? Wrote that really small. x plus 2y equals 5.5. Okay? Right? Now if I bring my other equation down, Maddie, we have 3x minus y equals 6. Are my x's in the same column?
Yes.
Are my y's?
Yes.
Are my equal signs?
Yes.
Are my no variables?
Yes.
Yeah. So now everything's in the same column. So now I can proceed to step 1.
Okay.
Okay? So, step 1. Examine the system. Find coefficients that are multiples of each other. Okay, so if I look at the system, you guys see any coefficients that are multiples of each other? Any coefficients that are multiples? Oh, 3 and 6, but they're not coefficients. They're just 3 is a coefficient, 6 is not. Remember, coefficient is the number in front of the variable. Jordan, pay attention. Stop talking, please. Okay. So, what do I do? You said 2 and what?
Y.
And y? Well, the y has what in front of it, guys?
1.
A 1. The x has what in front of it, guys? A 1. Are 3 and 1 multiples?
Yes.
Yeah, are 2 and 1?
Yes.
Yeah, so really you could pick either one.
Let's pick 3x.
3 and x, okay. So if I want to pick 3 and x, that means I got to multiply the top equation by what? 3. Okay. So we pick 3 and x, so I got to multiply this top equation by 3. Right? Does that make sense?
Yes.
Better? Okay. So 3 times x is what? 3x. Right? 3 times 2 is what? 6y. 3 times 5.5 is? Something. Thank you for being so helpful. 16.5. Okay. Now, what do I have to do to get rid of my variable? What variable are we trying to get rid of here? X or Y? X, because x's are the same coefficients, right? What do I have to do to get rid of the x's? Yeah, you're right. Be confident, Mom. Okay, what do I have to do again? Subtract. So we need to subtract the bottom equation from the top equation. Right? Does that make sense?
Yes.
Okay. So 3x minus 3x is what? 0x. Negative y minus 6y. What is that?
Negative 7y.
Negative.
Negative 7y.
Good. Negative 7y. 6 minus 16 and a half.
Negative 10.
Good. Negative 10.5. Andrea, you got a question? No? Okay. Make sure you're paying attention, please. Okay. So, what do I have now? What have I eliminated, guys? X. So now we have negative 7y equals negative 10.5. What do I do now? Divide by negative 7. Right? This is step 3 now. Solve for the thing remaining. 10.7 divided by negative 7. Or sorry, 10.5 divided by negative 7. 1.5? So now we have y, don't we?
Yeah.
To find x, we take this and plug into either of these two. Which one should we use, top or bottom? Bottom, okay. It's like we're like in tune or something. It's crazy. Because I would pick the bottom one too, because it's already solved for the x. It's real easy. You would pick that one too?
Everybody would
Very good.
pick.
Okay. So 5.5 minus 2y, right? But what's y now? 1.5. So 5.5 minus 2 times 1.5. What's 2 times 1.5? 3. So 5.5 minus 3. There we go. There's our solutions. 1.5 and 2.5. Okay. Does that make sense, guys? Okay. Now, I understand you're probably a little uncomfortable with this right now because, 1, it's a new method, and 2, it's really weird compared to what we're usually doing.
Yeah.
Okay? We're subtracting equations, we're multiplying both sides by the same number that doesn't really get rid of anything. Okay? But when you get some practice with this, I'm pretty sure you'll like this one the best. All right? All right.